Okay, in this lesson, we'll learn all about transmission and transparency ray depth. These bottles have a glass shader applied to. In the lesson, we discussed transmission samples. I briefly showed you how to create glass shaders using standard surface. You can just simply set the transmission weight to 1, or you can just use the glass preset for now until we, in the shading section, go in depth and talk about all of these parameters in the standard surface shader. Now in this scene, I have decreased the roughness to about 0.01. So we have a clear glass shader, not a frosted one. Now, besides transmission, we have another thing called transparency or opacity. As you can see, I have these 4 cubes under this cloner as well. I can unhide them and hide the bottles for now. Let me create a new Arnold standard surface shader and rename it to transparent. Also apply to the cubes. Let's change the base weight to 1 and change the color to this turquoise color. And set the specular weight to 0 so we don't get any specular reflections. If you come down to the geometry section of the standard surface shader, you can see we have an option called cutout opacity. You can use this opacity to create semi-opaque, transparent, or fully opaque shaders. For example, you can apply a checkerboard pattern to this channel. Where the pattern is white, you are going to get fully opaque surface, and where there is black, the surface would be completely transparent. Now let me reduce the opacity to something like 60%. And now as you can see from the IPR, we get a semi-opaque shader. And that's how you add transparency in Arnold. For now, let's hide the cubes and unhide the bottles. We'll visit them later on in the lesson. Now let's open up our render setting and discuss transmission and transparency ray depth. Transmission ray depth controls the maximum number of times a ray can be refracted. At the moment, our transmission ray depth is 8, and that is why we see these black panes in our bottles. If I set the transmission ray depth to 0, you can see our bottles no longer have any refractive or transmissive qualities. And as I start to increase my transmission ray depth value, we slowly get rid of those black panes because we are allowing our transmission rays to propagate further in the scene. If you think about it, we have 4 bottles because this model has kind of thick walls. Each bottle has 2 fronts and backs, so we need at least 16 transmission ray depth so our transmission rays can evaluate all the bottles correctly in the scene. But the problem is, as you notice, increasing transmission ray depth only reveals more glass panes until we reach the value of 10 ray depth. And as I'm increasing it to be more than 10, so we can get rid of the remaining black panes, it does not change anything. And that is because our total ray depth limit is set to 10 up here. Total ray depth controls the maximum number of bounces any ray can have in the scene. So because the total limit is set to 10, none of these ray types can have more than 10 depth. So let's increase the total limit to, let's say, 16. And now I can increase my transmission ray depth to more than 10 and get the expected result. Let's set it to 16, and now we have clear glass panes all around. Now down here we have the transparency depth. Here you can control the number of allowed transparency hits. Now let's focus on our cubes that we have transparent shader applied to. At the moment, the transparency depth is 10, so we can see our transparent cubes the right way because we have 4 cubes and they have a front and a back side. So in total, 8 transparency depths should be enough for multiply by 8. Now let's decrease our transparency depths to 0 and see what's going to happen. First of all, as you can see, our transparent cubes are solid and fully opaque. And as I increase my transparency depth, we are getting our transparent cubes back one by one. So by increasing this value, we are allowing more rays to pass through our transparent surfaces, and also setting this value to a low number like 0 make Arnold treat the object as opaque objects. Always remember, in the ray depth section, you control the number of bounces, but to increase the quality and reduce the noise amount, you need to use the sampling section. And in this lesson, for example, if we had the right number of transmission ray depth, but our refractive objects still look noisy, we could go to the sampling section and increase the transmission sampling to reduce the noise in our rough transmission objects. So we are done with sampling and ray depths. Volume sampling and ray depth will be discussed in the Arnold volume lesson later on in the course. I will see you in the next video.